Hello to everybody. My name is Diana. I'm going to present my research work, which calls Energy Potential of Kaskelen River in Kazakhstan. Everybody knows that the main task of sustainable development is to adapt to climate change. In particular, these measures involve the rational use of local energy resources. Appropriate actions are also being taken in Republic of Kazakhstan. In the program of the development of hydro and wind energy in Almaty region for 2006 and 2015, there is a list of rivers where the Kaskelen River is one of the potential rivers. Namely, this river is suitable for small hydropower plants. And the relevance of my work is that the relationship between climatic factors and hydropower in my research area has not been studied yet. So, in my research work has two significance. It's practical and social. First of all, practical importance of my work is to analyze the effects of climate on the hydropower plants and provide options for adaptation and mitigation to climate change for small hydropower plants. What about the social importance of work? It's for the local population where demographics are growing every year, as well as the need for electricity. Accordingly, high water in this period will be good for the local population. Based on this, the aim of my research work is to assess the past, current and future state of water resources of the Kaskelen River against the backdrop of climate change. So according to my aim, I have several objectives. It's to collect the data of my research area and river, to determine of hydropower potential of the river, analyze of dynamics of the Kaskelen River for 80 years, determination of the relationship or dependence between the water temperature and water flow, and identify of electricity consumption in the Kaskelen city. My research area is located in southeastern of Kazakhstan in Almaty region. The object of study is Kaskelen River. Kaskelen River is the left tributary of the Ili River, which originates on the northern slope of the Ili skeletal. The length of this river, 155 kilometers, and the basin area is 3,620 square kilometers. So the my methods is to define the theoretical hydropower potential. It is the total theoretical sum of the river flow energy, and I use these two formulas. And for defining the dependence of water temperature and water flow, I use Spearman's correlation coefficient. In this slide, you can see the multi-year average annual discharge of Kaskelen River over a 100-year period. For a more accurate description for the result, I used a 4-degree polynomial trend, which gives a largest approximation value, which is 0.21. This trend shows fairly systematic fluctuation over the study period, as you see. The period under consideration can be divided into three parts, where from 1930 up to 1950, the average annual flow rate is 4 cubic meters per second. Then since 1955, there has been an increase in the water flow, where the peak of flow rate is 5.88 cubic meter per second. It is in 1973. And the lowest runoff occurs in 2000s, where the average river flows is 3.5 cubic meter per second. After 2000s, there is an increase in runoff to nowadays. The Kaskelen River has a good growth potential. The total potential of the whole river, it is 450 megawatt per hour. When in studied segment, it was 800 kilowatt per hour. In this slide, you can see the dependence between flow and the temperature of the Kaskelen River from 1971 up to 1975. This dependence was determined using logarithmic regression. The choice of logarithmic regression is due to the fact that the logarithmic trend shows a greatest approximation, which is 0.87. And the Spearman correlation coefficient was also calculated, which is equal to 0.89 with a significance level of 5%. This significance of the correlation coefficient confirms the relation between water temperature and its flow rate. With connection allows us to say about the flow rate from a practical point of view when measuring the temperature, since it's easier to measure the temperature than the flow rate. From this, we can identify the hypothesis that the process of flowing from the source or mouth of the river to the measured hydropost, the water has time to change its temperature under the influence of air temperature. Every year, the number of people in Kaskelen grows as a consumption of electricity also. So according to statistics, in 1959, the number of people in Kaskelen was 2,000, and each person consumes about 60 kilowatt per month. This amounted to about 700 megawatt per month, and in 2018 it was 5,200 megawatt per month, and 2055 it will be 30,000 megawatt per month. So the main achievement of my research work, it is a quantitative description of the impact of climate change on river water availability, confirmation of the assumption that warming will positively affect the current hydropower potential of this river. And the main achievements of my work that the Kaskelen River has its own systematic cycle where fluctuation change from lower water period to higher water period, and this every cycle has 30-year period. Currently, the river is in high water period. So, as I said, Kaskelen River has a good growth potential, which was 450 megawatt per hour, and this research point, it was 800 kilowatt per hour. So, which allows the construction of several small hydropower plants. But however, for small hydropower plants need separate calculation and separate project for each small hydropower plants. The relationship between the temperature of the river and its discharge has once again proved the dependence of river flow on climatic factors. Knowing this pattern will allow to us to quickly assess the short-term fluctuation in the river flow. So, based on these results, I made some recommendations. Taking into account the consequences of climate change, it's recommended to consider an approach to energy not only in Kaskelen River but also in entire country as a whole. This work has shown that it's necessary to develop a fundamentally new approach to energy and calculation, as well as to structures also. And also we have to take into account climate change. These recommendations determine the energy independence of Kazakhstan and will ensure overall development and, of course, reduce the risk of environmental pressure and climate impacts. In this slide, you can see the main resources which I used for my research work. Thank you for attention.